Welcome, everybody, to this week's Fireside Chat. I'll be your host, Marlon Ruiz. Today's special guest is Sergey Gorbunov. Sergey is currently serving as a co-founder for Axelar. Before we begin our chat, let's go into the background a little bit for Sergey. Beyond being a co-founder for Axelar, he currently is an assistant professor at the University of Waterloo. In the time before time, he was founding team member of Algorand. He earned his PhD from MIT with a Microsoft Fellow. He was also awarded the Sprouse Doctorate Thesis for Best Thesis in Computer Science. Welcome, Sergey. Thank you for joining us.
Thanks for having me, and thanks everyone for joining.
We usually start with a personal story, intro to crypto. In your case, I would love to peel back a little bit on the history you have in your studies where you were focusing on networking, software-defined networks, and cryptography. Can you talk a little bit about how you combine those two things and how that actually brought you into the space?
Yeah, no, for sure. I guess even going back before the PhD, right? When I was going to grad school, I had like this path where I try to think about, do I want to focus on like computer networking or cryptography, right? So I did like some computer networking before that, like in software-defined networking and things like that. And then, I couldn't really make up my mind. And so I ended up doing cryptography because I thought that was, the more interesting path for me to study at the time. But then by the end of, grad school at MIT, trying to understand like what are still big important problems that need to be solved outside of my PhD, right? So I had my thesis done. I knew I was going to graduate, and I had about a year of freelancing in some sense to think about other problems. And Bitcoin was on the rise. Ethereum was still in the very, very early days, I really got fascinated by a lot of the problems, right? And I think what drew me originally was really the combination of blockchain technologies or Web3 being a beautiful, marriage of networking, cryptography, economic incentives, right? So and you can have very, very interesting technical concept from either one of these areas, and they're all kind of get combined and they all get married together in these blockchain networks and provide very unique and special properties. And so that drew me from a very technical perspective, right? And when we're looking at Bitcoin and Ethereum at that time, your first reactions as a kind of researcher, right, is, well, we can do better, right? And then what does that better mean in terms of throughput, performance, energy savings and things like that. And those were kind of the initial inspirations to actually go and work on those topics full time.
Oh, that sounds cool. Yeah, there's a lot of folks that talk about TPS and how many transactions can you do. So yeah, that's very interesting, and I wonder, what is the real winning situation? Is it about TPS, or is it about security? Is it about a mix of everything? So those are good things that I definitely enjoy considering.
Yep.
So if you could tell us a little bit more about how you got to Axelar. I know that you were a founding team member for Algorand, so that's a great start that you got in the industry. That sounds very exciting. Can you talk about how you did that transition, and what was it about Axelar that said, hey, I have to go co-found something and create this new thing that hasn't lived before and breathe life into it?
Yeah. So with Algorand, we really try to solve scalability issues that we've seen in blockchains, right? Like Ethereum or Bitcoin. Basic question, how many TPS per second? What does the developer environment needs to look like? How do you not have all this electricity waste that goes behind producing all those blocks, and how do you do something more efficient, right? So Algorand was, the platform that was designed to address those scalability questions. And you have fast consensus, you have decentralized network, and so on and so forth. And the first thoughts about the kind of connectivity came out after we launched Algorand, right? We launched it, and then we, had to think about how do we get users and developers to build on top of it, right? And the first thing that they tell us is that, okay, I love the platform from a technical perspective. It's cheaper, it's more efficient. I can go and build on top of it. but I have users' liquidity elsewhere, right? Like on Ethereum in particular. So could you guys bring that over, right? And like we at Algorand were like scratching our heads, like, well, okay, like we can't do this right away. Is there a provider we can call to, connect us with Ethereum or Bitcoin or all these other networks to bring this liquidity or allow users to, migrate? And nothing was really available, right? Like there's no protocol you can plug in. There's no provider that you can call to do the work or anything like that. And so that was the kind of our first sparks, right? About the fact that, as we're building Algorand, many other blockchains were built, right? And we realized that they're all going to go through the same issues of bootstrapping effectively, right? And bootstrapping means like having connectivity with other networks. So those were kind of first thoughts. But then beyond it, I think when you think about it and kind of go back to the question of, how many chains do you want to see at the end of the day, right? Or should we see at the end of the day? You realize that for very, very technical reasons, you have to have kind of horizontal scaling strategies for technology stacks, right? And these horizontal scaling strategies could be named differently. They could be named, sharding, layer 2s, layer 1s, and so on and so forth. But when you have those horizontal scaling strategies, then the question is, how do you connect them all together, right? How do you still interoperate, and how do you allow information flow across all these different, shards or layer 1s or layer 2s in some sense? And so, at that point, it was very, very clear that cross-chain communication, right, and that interoperability across all these layers is going to be incredibly fundamental to help ecosystem scale. Right? And I thought technically it's a hard problem. It's a needed problem to solve, so let's do it full time.
Yeah, that makes sense. Thank you for sharing that. If you think about the space you're in and the news that has been in the past as far as bridges and vulnerabilities, what's Axelar's approach, your approach to kind of securing your chain, securing those transactions so that it's less prone to hacking and those kinds of incidents? Would love to understand a little bit more about that.
Yeah, so I think if you look at first of all, I think it's important to understand like why we're seeing all the hacks and attacks, right? And I think beyond just like the technical why, I think it's important to understand kind of the historical, again, like concept for why we saw those bridges in the first place, right? And the reason is because we saw the demand for interoperability across chain before the solutions were available, before good solutions were available, right? And so as a result, you ended up with just an array of very cheap, protocols, not cheap, but very insecure protocols being rolled out by different providers. It's very easy to put a centralized interoperability protocol, right, across two different chains. You spin up a database, done, right? You put a cryptographic key in the database, you connect this database with two blockchains, and that database can send messages back and forth between blockchains. Very easy, right? But it also doesn't take much to take down or compromise this protocol. You just attack the database, extract the key, and you can break the security of that bridge. So that's what we have seen, right? The demand kind of outgrew the good quality supply in some sense, and so you had lots of centralized protocols being rolled out. A lot of them got hacked because there's only a few keys that need to be compromised, or they haven't gone through security audits or rigorous testing before they shipped, and pretty bad designs overall. So that's one thing. And I think to do interoperability or cross-chain communication securely, you have to take a full stack approach, right? So what is the ground layer that has to be built? You have to base your technology based on open, decentralized protocols, right? That's how you get trust. That's how you get security. That's how you get strong liveness and safety properties from this network. So you have to start with that. And that's fundamental. And that's what Axelar is based on, right? It's a decentralized proof of stake network. So that's great. That's a great start that you have to have. But then on top of it, if you think about how do you actually build a secure system, you have to have good engineering practices, right? Everything from rigorous tests to audits, done like over 30 audits. You have to have bug bounties. We run like multi-million-dollar bug bounties on top of Axelar, end-to-end tests, stress tests, and things like that, right? So key rotations, pretty important. So all those things that kind of in traditional systems people know of, right, and know how to do, they're not easy to do, but you do have to apply them to the blockchains as well if you want to make something secure. So that's the second layer that has to be built on top of these core protocols. And then the final piece that adds to the security is what we call as like application-specific add-ons, right? So for instance, if you're transferring value from one chain to another, you probably should have things like rate limits of how much of that value can be transferred, per hour or per minute, right? Most traditional systems have those types of properties. There's no reason you cannot bake them at the protocol layer into these applications. And so then application can have additional safeguards, right, in case other layers are compromised. And so things like rate limits, things like, traffic detection at the fingerprint level, and so on and so forth. All those things can be added at the application layer to make it even more secure, right? And I'm not only talking here about actually cross-chain, but I think more broadly in Web3 space or smart contracts, we're seeing that trend of application-specific security add-ons being added more and more. So that's how we think about Axelar. It's sort of a holistic approach that starts with the right design and with the right core network built on top of strong engineering practices, right? And add-ons for the applications that actually make sense to make them most secure.
Cool. Thank you for sharing that. Since we're talking a little bit more about the development of your chain, can we talk a little bit about the languages and how broad that is? How even some folks are even developing their own ways of communicating within your chain. I know Solidity's out there. You got JavaScript. You have Rust, WebAssembly as one-offs. So just a little bit about like how you approach that. Is there just one language you would really want to be the only language, or your general thoughts?
Yeah, so our kind of a philosophy has been to really empower developers to build using any stack or any language that they want, right? But still be interconnected with everything else, right? So that's exactly kind of how Axelar has been designed in order to plug in with different kind of layer ones and layer twos that can speak different languages or have different smart contracts on top of them, so that developers building on them can still pick that platform for the technical characteristics, right? Like I like, Rust or JavaScript, whatever it is that you like. You can build on the chain that has those properties, those languages, those decentralization and security features, but you still can connect with other networks, right? Can still send packets back and forth and connect to the user. So I think overall we're still pretty early in the language development, right? And Web3, I think Solidity clearly has the dominance, right? I think the Electric Capital put a developer report a couple of weeks ago where I think they say something like 37% of layer ones have Solidity today for EVM environments. So that's continuing to be the dominant platform. But you do have other platforms that provide Rust or JavaScript languages that I think a lot of developers want and a lot of developers would like. So we want to let them build there, right? From our perspective, and let them innovate across those stacks because it's still incredibly early. So we'll kind of see what ends up happening at the end of the tunnel.
Yeah, that's wonderful that you want to give the developer the choice, and you don't want to be restrictive on how they do things and make it more open. So that seems like a great strategy. Speaking of working with partners and other chains, how exactly do you partner? I recently saw a video of you showing how to add to, I believe it was the Avalanche chain, and it was just running some containers in Kubernetes and being able to do that very easily. Can you talk about that process for adding new partners and maybe the partnerships that you have specifically?
Yeah, so let me address it like in two parts. I think part one is how do we work with like layer ones, right, or networks that we connect, and then how we partner with applications, right, that are built on top of these layer ones. So to the first part, Axelar itself has been designed with a kind of a plug and play model, right? So if you look at the network stack itself, the whole idea was to be able to plug into EVM and other types of environments by running commands on the Axelar network. Once validators on board and like certain checks are done, then you can literally run like routing types of commands to register a connection to a chain, and then that chain becomes automatically activated with the other networks that will connect. So there's nothing that we need in terms of kind of a partnership or support from a layer one themselves in order to integrate them. And that was actually a core requirement that we have for Axelar, is because there are some protocols that you may want to use for interoperability. Actually, you require you to rewrite parts of the consensus, which we thought makes no sense, right? If you're building a consensus or layer one, and then interoperability protocol that you want to integrate with would require you to change how it's implemented. That's a lot of work, and it's a lot of engineering resources that have to be spent. So plug and play approach has been at the core of how we design the network, and so we connect pretty easily from a networking perspective. And then layer ones themselves, kind of from a partnership perspective, they help us reach their developer audiences, right? So in the same way as layer ones have to tell a story about what is their unique value, right? One of the pillars that they have to provide is that what is their answer for interoperability, right? So it's what is my security, what is my scalability properties, what is my smart contract language, how do I answer interoperability for my developers, right? And so layer ones have to give those answers to their developers, and by plugging in or partnering with Axelar in this case, or the network, they have those answers. So that's when it comes to layer ones. It's plug and play approach, but of course, kind of working with the partner networks on the distribution. And then from an application perspective, on top of it, the network is completely permissionless in a sense that anybody can build, and anybody can use its protocol to send arbitrary cross-chain contract calls or perform arbitrary types of asset transfers, right? So in the same way, if you're building on top of Ethereum, you can write a Turing complete smart contract that does interesting functionality. You can do that on Axelar. You don't have to kind of ask anybody for permission. It's completely open, and that's what the power of decentralized networks gives you. We do have, of course, like various partners that are building using this framework. Some examples like Circle, right? So we announced like a partnership with them a couple of months ago on this building block called like composable USDC, which I think is pretty exciting. Polygon is another partner that we announced the partnership with. Osmosis is one of the DEXs that we're working with to integrate cross-chain swap functionality. So yeah, kind of lots of different application and integration partners that we're working through.
Perfect, thank you. I would like to pull a few strings on that last little bit. Let's start with Polygon. There's a lot of ideas about how do you connect the Web 2 environment with the Web 3 environment. Does it have to be native Web 3 in order to play? Perhaps maybe a little bit of discussion around what your thoughts on that, and is it a winner take all, or is it a let's transition and we can be in two puddles at the same time, so to speak?
Yeah, I mean, I think there's needs to be more and more integrations between Web 2 environments and Web 3 environments in general, right? I think unfortunately right now the Web3 community, it's sort of it's its own isolated world, right? And its own isolated world, it has its own funding, it has its own community, it has its own like developers, it has its own kind of use cases and customers in some sense. And so it's all working in parallel with traditional software stacks, with traditional financial instruments and so on and so forth, which is fine. Allows it to kind of innovate and be fast. But I think over the years, as the technology matures, right, as the use cases mature, we're going to see more and more integration points, right, between the traditional software deployment stacks and Web3 deployment stacks with traditional kind of a payment rails and Web3 payment rails, right? In my mind, if you're building an application kind of a 5 or 10 years from now, blockchain, right, the technology or Web3 stack is another sort of kind of a choice that you have to make. Do you want to use it, yes or no, right? And you have to be very thoughtful about kind of properties that it provides. You have to be very thoughtful about kind of performance characteristics, security characteristics, and so on and so forth. But it's almost like becomes an option in your deployment, right? You can imagine like you write your application and you want to deploy it like through Kubernetes, and you say, oh, I want to deploy this using like MySQL database, right, or Postgres, or I can deploy it using like a blockchain like layer 2, right, at the back end, and I'll have some other properties. Maybe it's a little bit slower, or maybe it's a different language, but then I'll have like trust and verifiability engraved in the application, and it kind of becomes a part of your deployment cycle. So yeah, I guess like my hope is over the years we're seeing more and more glues and interoperability between Web 2 and Web 3 stacks being built so that everybody understands precisely what is the value of each individual software choice that you make, and which one makes sense for your use case.
Okay, that's great. Thank you for that detail. The other thread I want to pull on is, stable coins. You mentioned Circle and your partnership. Can you talk a little bit about why is that so important? What is that unleash when we can have stable coins moving wherever they need to move? Just talk a little bit about that, perhaps, because I think that would be interesting.
Yeah, so I think stablecoin is a necessary kind of a building block to build financial applications, right? If you look at any layer one that try to bootstrap in the early days, stable assets and stablecoin is the building block that you have to have there in order to build a community and build applications around it. Every time during financial cycles, stablecoin is used, right? Either more or less, people either convert the assets to stablecoin or vice versa. And so, it is a core building block that just needs to exist, right? From our perspective, this building block of stablecoin also needs to be used to connect different applications across the ecosystems, right? So, as an example, let's say you have a decentralized exchange on Ethereum, and maybe you have another decentralized exchange on Avalanche. Can you connect them together, right? And so what ends up happening is that you could actually connect them together by composing liquidity between them, right? And so how do you do that? And one way of doing it is by using kind of stable coins to compose this liquidity and route the liquidity between them, right? And so, work with the stable coins like USDC we're doing is effectively a gateway to allow applications that are built on one chain to talk with other applications in order to expand their reach or distribution, right? And in this particular case, being stablecoin as the kind of routing liquidity asset that you can move back and forth to talk with another application on the receiving end. So that's why I think it's pretty interesting and exciting. And as we see more chains and as we see more interactions between them, I think a lot of those interactions will be through the movement of assets, and stablecoin being one of the assets that of course needs to move.
Gotcha. Digging a little deeper on that, there is a lot of angst maybe or confusion around transparency and privacy with respect to stablecoins. When we go to decentralized world, we want to have some privacy and also contribute and be a part of the system. How do you balance those kind of worries with what you're doing and what you see in the partnerships that you have?
Yeah, so I guess two separate things, like transparency versus privacy, right? Like in some sense, building on a blockchain gives you the transparency, so you can audit precisely what's happening, right? And you can do that either for helping you doing record keeping or account management, or you can do it to identify malicious or criminal activity within it. It's all very, very easy. But like you said, the privacy is sort of compromised. That being said, there's a lot of interesting technologies that I think enter in the space that can address the privacy concerns, right? So I think probably many of here know about like zero knowledge protocols, which are kind of a fundamental building block that's been used to solve both scalability but also privacy concerns, right? So the idea is that you can use things like zero knowledge proofs to hide information about your application or your asset or your transaction history, but you can hide it and still be able to verifiably prove ownership of it, right? So like if you have a stable coin, maybe that stable coin is then encrypted with a zero knowledge proof, with a encrypted with regular encryption, but when you transact with it, you attach what's called like a zero knowledge proof to prove that you still own that coin, right? Or when an application executes an action, that application can generate a zero knowledge proof that it performed the right action without revealing the details of its state, right? So I think an incredibly powerful building block. So I think we're going to see more and more of those privacy techniques and privacy solutions being applied in the blockchain space as well. There is a wrinkle though, and I think the wrinkle is that these privacy techniques often break composability, right? With the transparency aspects of it, right? And I think the question is, are we going to end up with 5%, 10% of all transactions or applications being encrypted in this privacy preserving way? Is it going to be the whole space that ends up being encrypted with this privacy preserving layer? I don't know, right? And I think that's a good question. But I think a part of that answer will have to come down to how composable those privacy primitives are with all the primitives and all the objects that need composability natively.
Okay, thank you. One more question on the idea of stablecoins. You have this idea that we definitely need them. Thank you for explaining in more detail your thoughts on that. But I wonder about something like UST, Terra, that whole stablecoin algorithmic challenge that we had. So can you talk about that a little bit? And I'm sure everybody was thinking that was the winner. It seemed like Do Kwon was, solve the problem of the universe. Here we go. Here it is. If you could talk about that and how that maybe that impacted you and how you consider, choosing stablecoins to interop with, and how you make those right decisions at the right time.
Yeah, so we integrated with Terra, right, as one of the networks as well, and we're supporting like UST flows like in and out of different ecosystems. It was one of the networks that was live, so kind of lots of activity for UST between like Terra and Avalanche and other networks. So it was kind of lots of definitely traffic flow that we saw there during the kind of Terra collapse. It was actually quite interesting where first we actually had to protect all the different ecosystems that were integrating and using the UST through the Axelar stack, because when the Terra network itself was going down, there were concerns where, like somebody could attack the Terra network to mint assets, right? Or issue like completely like infinite supplies of coins that will then be, polluted into other networks, right? So we actually, and then the Terra network itself went down. So Axelar protocol actually kind of paused the connection with Terra, and then like Terra resumed, like the protocol resumed the connection, and so on and so forth. So from a security perspective, it was actually good to see all the safety features that we put in at the protocol layer actually being kind of executed in practice when one of the networks that we connected, went down. I mean, that being said, I think, couple lessons learned from Terra UST. One, it's very hard to build, stable coins, right?
True statement. Just ask Do Kwon.
I mean, it's whether or not you're taking like the centralized route, right, like Circle is doing, and like a formal kind of regulated path, right, and making sure everything legit, or you're taking a decentralized path and trying to come up with a decentralized protocol and like some type of a pegging mechanism. I think both of those paths are hard, right? For different reasons, but they're still hard. I mean, that being said, I think the other thing though, like a lot of the UST and Terra mechanics were on chain that people, pointed out towards, right, and said there could be, maybe some issues with this mechanism, like how it's, defend itself with this attack or that attack. So from some sense, the transparency of the mechanism was completely on chain, right? Maybe it wasn't addressed by the community or the team and so on and so forth. But I think it was certainly not the case where people said, well, like we didn't know about this, we could not have even predicted about it. It was almost the opposite. People like, well, I looked at this mechanism, 6 months ago, and I thought this was vulnerable to different attacks, and so people can take their own risks associated with it. And in contrast, if you look at kind of a lot of the centralized vendors that also failed over the last year, right, that was completely opposite, right, where people kind of trusted them and they took all the trust properties behind them. But when you actually look under the hood, what's happening, everybody was like shocked to see how broken those mechanisms were, right? So while I do think that it is unfortunate, I think a lot of money was lost at the Terra collapse and so on and so forth. If nothing else, I think it just reinforces the need for decentralized protocols and improvements over decentralized protocols, right? And addressing issues with them when they do arise, and kind of continue building them. you had coins and stable coins being issued by centralized exchanges, right? And now we have no idea what's going on behind those, right? Now we have to, speculate and stipulate. So, yeah, like it's hard to build, but we need to kind of continue building and innovating. It's certainly not an easy category.
Great, thank you for that. When you think about the future for your chain and kind of the industry all around, what do you see coming? I mean, is there something you're focused on? Hey, I have to do this in the next 1 to 2 years, or separately, as an industry, everyone needs to focus on. How do you feel about that, or what are you thinking is really the next step for our evolution, as a Web3 community or a larger community?
I mean, I think one of the big lessons we learned from the last bull cycle was really the fact that multi-chain experiences for the user sucked, right? So as a user, you use one chain, you pay gas there, you use like some application, maybe you heard or saw another application on a different chain, and then you think about, how do I bridge to that chain? Maybe do I need gas for that chain? Oh, what wallet do I need to download to actually play with that chain, right? And then, it's like 15 clicks and like 10 different transactions until you play with an application. And I was actually onboarding somebody from my family to a Cosmos chain, right, in the early days, like last year, and they love it. And then they're like, oh, I saw this application. It's on this thing, Ethereum, right? They didn't know what Ethereum was, and like, I really want to play with it. And they're like, oh, but I need to move some coins, and like, what are like bridges available, right? And kind of how do I do all those things? And then an hour later, we were not live at that time, so they couldn't use Axelar. But an hour later or so, until they figure out all the paths, I tell them, by the way, it's going to cost you $100 to perform like this transaction? Like, no, like, I put $20 right in my experimentation. I'm not spending $100 to play with an application. So I think the multi-chain experience just sucked, and I think they, this is our big focus over the next year or two, or beyond that with Axelar, is to make sure that as we scale the ecosystem, as more chains or layers are available, both developer experiences for building a multi-chain are simple, right, and are accessible and easy to use, and also user experiences are simple, where at the end of the day, the experience that I want to see is that I have a wallet, I have an asset, I see an application, I go and use it. Okay, I don't have to think about gas, I don't have to think about bridging, wallets, swapping, and so on and so forth. And that's not there yet, right? And I think that's fundamental to solve if we want to onboard more users to the ecosystem, because we lose them every time we tell them it's it takes $100 to kind of do this interesting transaction that you were thinking about, and we'll lose them when the experiences suck, right, or when the interactions across those platforms are complicated. And I think that's an important problem to keep pushing as an industry, beyond just, of course, security and scalability, which we do have to address, and we can get there, right? I think, like right now, like this video call is actually a good example of us interacting across multiple networks, coming in from different countries, different worlds, all kinds of very, very complicated protocols happening under the hood to route our packets and deliver them to one another, right? And kind of a meet at the Google Meets right now. And but the experience and the interaction with these applications and with each other that we have is very, very obfuscated or abstracted away from all these underneath networking and systems. And so this is what I want to see in kind of a Web3 space as well.
Yeah, it's kind of like we need to apply the KISS acronym to everything we do. Keep it simple, S, you know what I mean? So that's something I've experienced my whole life. And when I was a programmer 1,000 years ago, as a younger person, I was thinking to myself, okay, I'm just going to do what I do. And then my teacher would say, no, just keep it simple. You got to keep it simple. And that applies to so many things in life, but definitely applies here as well. Perfect. Thanks for sharing that. I think you have an event coming up. I mean, there's a larger event in February, ETH Denver, but I believe you have something that you're setting up for your community. Can you talk a little bit about that?
Yeah, so ETH Denver is happening at the end of February, right? And we are hosting an event. It's called the Interop Summit. So you can go to interopsummit.com right before ETH Denver, right? And the idea is to bring a lot of the partners and networks that we connect together to talk about what does this, interchain future look like, right? Like, how should it look like? What are the infrastructure pieces that are still missing? How do the applications architectures need to change with it? And so the Interop event itself is really kind of a gathering of community and builders that build in around Axelar or other protocols, right, in this space, but with the goal to think about how do you build the next generation of application build outs from both architecture perspective, user perspective, but also funding and other perspectives, and kind of how you scale them. So I'm pretty excited. It's going to be held in Denver, February 27th, 28th. So if anybody is around, come by. I think it'll be awesome.
Wonderful. Thank you for sharing that. Thank you to our guest, Sergey. Really appreciate you taking the opportunity to come meet with our community, and wish you all the best in everything you do in this next couple of years, and looking forward to seeing, what you guys come up with.
Awesome. Well, thanks so much for having me, guys, and great questions. I really enjoyed the discussion.
Perfect. All right. Cheers, everyone.